Alright, let's move on to question number 4. Question number 4 tells us, consider the linear pattern 5, 7, 9. So a linear pattern is the same as an arithmetic pattern or arithmetic sequence. So the same thing as arithmetic. So we've been given 5, 7, and 9. Question 4.1 asks, determine term 51. Alright. So question 4.1 asks us for term 51. So if we have 5, 7, and 9, it means that our common difference of that we call D is going to be 2. So the difference between 5 and 7 is plus 2. The difference between 7 and 9 is plus 2. Therefore, D equals to 2. A is our first term, which will be 5. And for a arithmetic or linear pattern, your general formula is Tn equals to A plus n minus 1 times D. Okay. Therefore, Tn equals 5 plus n minus 1 times 2. Okay. And term 51 would be calculated when we substitute 51 for n. So 5 plus 51 minus 1 times 2. This is going to be 5 plus 100, which equals 105. And that is our 51st term. Okay. Let's move on to question 4.2. Question 4.2 asks, calculate the sum of the first 51 terms. Okay. For an arithmetic series, to get the sum of the arithmetic series, we will use the equation given to us in our formula sheet for arithmetic patterns or series. So that is this formula here. I will outline it in orange. So it is Sn equals to n over 2 times 2a plus n minus 1 times d. Let me quickly explain what this equation calculates. What does this formula calculate? When we have Sn, when we have an Sn formula like this, we're calculating the sum of the terms. So you're calculating sum of the terms, you're adding up all the terms from the first term. This is important, from the first term to the n term, whatever we substitute in for n here, to that term. So we are calculating, we're adding up all the terms from the first term, from n equals 1 all the way up to n equals whatever number we choose. So we want to find the sum of the first 50 first terms. So we can say S of 51 equals to 51 over 2 times by 2 times A, which is 5, plus 51 minus 1 times 2, which is our D, our common difference of D. So this is going to be, let's leave this as 51 over 2 for now. We don't want to get any decimals. It's going to be 10 plus 51 minus 1 is 50 times 2, that's 100. And then we will have here 51 over 2 times 110. And 110 divided by 2 is 55, right? And then 55 plus 51 is 101. So this will be 51 times by 51 times by 55, and that result will give us 2,805. That is the sum of the first 51st terms. Alright, now we can do question 4.3. Question 4.3 asks us to write down the expansion of this function, that is a function, and it says show only the first 3 terms and the last term of the expansion. So this function is called a sum of function. So the function here is the sum of it's the sum of this equation 2n plus 3, where n starts at 1 and goes up to 5,000. So these are the terms that we are going to be adding up. From the first term, which is specified by the bottom number, up until the 5,000th term, which is specified by the top number. And the formula or the equation to give us each term is 2n plus 3. Okay, so this is our starting term, right? This is our ending term, right? And this is our formula, or yeah, we can call it a formula or a equation, call it a formula. So this is the Tn equals 2n plus 3 formula, for example. But we don't want to just find the term, the value of the term, of the nth term. We want to find the sum of the terms from the first term all up to the 5,000th term, where each term is calculated by this equation 2n plus 3. So the question asks to show only the first 3 terms and the last term of the expansion. So if you want to show only the first 3 terms, we will substitute only 1, 2, and 3 into n, and then to get the last term, we will substitute 5,000 into n. So for example, T1 would equals to 2 times 1 plus 3, which equals to 5. T2 would equal to 2 times 2 plus 3, which equals to 7. And then T3 would equal to 2 times 3 plus 3, which is 9. Then the last term is the 5,000th term, which is T5000 equals to 2 times 5,000 plus 3, which equals to 10,003. So now that we have the terms that we require, we need to answer the question by writing down this function, the sum of function, as in its expanded form, only showing the first three terms and then the last term. So the way we do that is we write this function sum of 2n plus 3 from n equals 1 to 5000 equals to 5 our first term, 7 our second term, and 9 our third term. Then, oh, sorry, this is incorrect. We do not put semicolons because this is a sum of. So basically it's a series because we're adding up each term. Therefore we say plus, and then we will put plus dot 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 plus 10,003 to show that there are numbers to be added in between, which is indicated by these ellipses, but we're only going to show the first three terms and then the last term. And because there's no ellipses after this, we know that 10,003 is the last term. And then this whole line will be our final answer. So let's do question 4.4 now. Question 4 asks hence, right? So hence or otherwise, meaning now after you did the previous question, calculate the sum of these two functions. Okay, so to find the first function, we'll take the first function here and find the answer to this function, then take this function and find the answer to this function, the sum of function, and then we will add them together. All right, so we know that the first function we have here is the sum of 2n plus 3 from n minus 1 from n equals to 1 to 5000, and we know that the expansion is 3 plus 5 plus 7, sorry, it actually starts at 5, and we know the expansion is 5 plus 7 plus 9 plus all these odd numbers up until 10,003. Okay, and if you want to get the same information for the second function, we'll have to do a similar thing. So for this function, the sum of minus 2n minus 1 from n equals to 1 up until 4,999, let us also find the first three terms and the last term, because in question 4.4 they said hence or otherwise calculate the following. So that means we must use the information we got previously, right? It's giving us a hint or a tip. So for this function, let us say that t1 equals to minus 2 times 1 minus 1, which equals to minus 3. So minus 2 times 1 is minus 2 minus 1. Then for t2, we can have minus 2 times 2 minus 1, that is minus 5. Okay, for t3 we will have minus 2 times 3 minus 1, which is minus 6 minus 1, that's minus 7. And then I'm sure t4 is now going to equal to minus 9, because it seems like it from the function that we've been given. It is an arithmetic function, so we're going to get an arithmetic series where there is one where there is a common difference between the terms, and the common difference here seems like it is -2. Okay, and let us see what our last term is. So T4999 equals to -2 times 4999 minus 1 equals to, I'm not sure, -2 times 4999 minus 1 will equals to minus 99,000, sorry, 90 equals to minus 9,999. Okay, so let us calculate what this equals to. -2 times 4999 minus 1 equals to minus 9,999. Okay, so this second sum of function starts at -3, then -7, then -5, then -7, then minus all the numbers up until, let's write -9, -9, then minus all the numbers in between up until the last value, which is minus 9,999. So they want us to add up these two functions, all right? So they want us to add up these two functions. As we can see, the terms of the functions are very similar. It just seems that the only difference is that one is positive and one is negative, all right? So if we have these two terms added together, what will we get? So let's think about it. We can write the first series on top here, which is 5 plus 7 plus 9 plus all the way up to 10,003. Then the second term we can write below it, which is -3, -5, -7, -9, up and all the way up until -9,999. And then what we are actually doing is we are adding this set of numbers to the top set, right? And this will equal to minus, so here we have 0, for example. You can say there's nothing in front of the 5, so it's going to be 0 minus 3. That is going to be -3. Then all the other numbers here, all these odd numbers would be cancelled off because we're adding 5 to -5, 7 to -7, 9 to -9, and these will all cancel off, right? So all of these values will cancel off. But this goes up to 10,003, and this one goes up to 9,999. If we subtract 2 from 10,003, we get 10,001. So if we find the second last term of this series on top here, if we find this second last term, it will be 10,001, and then the term before that would be 9,999. So we know that the 9,999 would cancel off with the last term of the bottom series. Okay, but there's nothing to cancel off the 10,001 or the 10,003. So we'd have to add that to our series here, or to our answer. So it's going to be 10,001 plus 10,003. Sorry, and 3. And then this is going to equal to minus 3 plus 10,003 is just 10,000, plus 10,001 is 20,001. An alternative method to this answer would be to use our SN formula to calculate the sum of these functions. So it will be using the SN formula, all right? And we can use the SN formula only because we are starting from term n equals 1 in both sum of functions. So the first sum of function is from the first term to the 5,000th term, and the second sum of function is from the first term to the 4,999th term. So only because we are starting from our first term, we are allowed to use our SN formula. So we can use the SN formula. The SN formula we can get in our data sheet, and that is going to, so the first one, we're going to write it out like this. So the first one is Sn equals to n over 2 times a, so a of our first a for our first sum of function is 5, and then the d is plus 2, so it's going to be 5 plus n minus 1 times 2, and then for the second sum of function, Sn equals n over 2 times the first term is going to be minus 3 plus n minus 1 times, what's our difference? Our difference is minus 2. So we'll have minus 2 here. So for the first one, if we want to find the sum of the first 5,000 terms, like they ask us in the question, then it will be S5000 equals to 5,000 over 2 times 10 plus 5,000 minus 1 times 2. And for the second sum of function, we need to find the sum of the first 4,999 terms, which is 4,999 over 2 times minus 6 plus 4,999 minus 1 times minus 2. And if you calculate this with your calculator, each one, and then you add it up, you should get the same answer, which is so if you add 1 plus 2, you will get 20,001. So this is our answer here, and this is the same answer here.